How was your week? And hope your weekend is bright. Sorry, my voice is a bit cracked. I'm not feeling too strong. So please
So
bear with my voice pending for now. Um, so I am going to be the facilitator for this course. This is SQL for data analysis. Um, I'm going to try and make it as practical as possible because my opinion about when it comes to learning is the more you do, the more you learn. So you're not going to have much slides. I'm going to go straight into um, basically practicals. We'll just dive in heads on. It's quite straightforward because um, SQL is probably one of the easiest languages to actually grab. It's not as difficult and as coin as the likes of Python. Um, so I hope everyone was able to download the SQL workbench that we shared in the link. So so let's start from the basics. Okay, let me share my screen. Let me share my screen. Can everyone see my screen?
Yes,
Hello?
we can see it. We can see it.
Okay, you all can see my screen. Okay, so we're going to just use this guide basically. I got this, I attended the course recently, so this was just simply output and it was straight up. I attended the course with CFI. So this was one of the materials I was shared and I felt it was going to come in handy. So when I'm done, I would share this with you. Um, so basically, what is SQL? SQL is structured query language. It's a language that is used to um, get answers, queries from databases, basically. And we have um, two basic types. Oh, let me spread it as two. So we have structured and unstructured. But for this reference, we are going to be working with more of structured databases, that is relational database models. Okay. So when we're saying structure, that means we're talking about the database that the structure entails rows and columns. You have columns and you have rows. And in this, these are the most common databases. You see them in places like Excel. Okay, that's structured. You have your columns and then you have your rows. You also have so each of those rows, those columns would be a parameter, a variable for your data set. Then you have the row as an identifier, basically. Um, so let me just quickly give you an example here. Where's my book? Okay. Sorry, hold on. Let me get just an Excel spreadsheet. Let me access an Excel spreadsheet here. So, okay, just a second. Okay. So yes, we have an Excel spreadsheet here. So this Excel spreadsheet, basically, you have your columns labeled A to infinity. Then you have your rows labeled 1 till infinity. So each of this holds a variable for your data. And this is exactly how it is in a structured database, in a relational database. And now I keep saying structured and relational. Now, when we talk about relational databases, that means just like the keyword itself says, relational. There's something in that database, the tables in the database that you can use to link the next table. So for example, let's give a database for sales, for example. Now that our database is for sales, in that database, we have tables that hold values for customer ID. That table that has customer ID has a column for the customer's profile, sorry. So that table now has customer ID, customer name, um, customer location, phone numbers. Then we now have another table on that database that holds product sales. So on that product sales, we have customer ID, we have the product name, the quantity, but the amount. So now we have two things we can use to relate. Okay, we have now on that table now, you want to get the total number of items a customer have bought. You can look at my customer ID, which is maybe 24, and go to the products table and merge the two of them. We'll get there. You merge those two tables. Okay, you do a join. Okay, you do a join, and then you can fetch data. It will give you a total sum of what I have, what I've actually purchased within whatever period it is you want to check. So that's just as short about it being a relational database. And then the fact that it's structured means you're expecting to see rows and columns. You have unstructured and semi-structured. So you get to hear things out like NoSQL, where you use keys and values. We're not going to talk about that here because that's another type of database. But most times, although a whole lot of technology is going um, towards the NoSQL portion of data creation right now, but most times the most common and most likely you are going to have to face is structured. So that's why we're using SQL today. So like I said earlier, SQL is structured query language, and because it's structured, you're expecting to meet a structured system. So let's look at what your workbench looks like, what our working tools is going to look like. So here we have the MySQL workbench. I hope everyone was able to download it. So it has.
No, please, I was
But
not
the
able
link.
to download it through
What
the
was the
link.
problem? Okay. After the class, would you just chat me up on Slack? Let me know what the problem is.
Okay,
So
thank you.
let me fix that. Okay. So this is my SQL workbench. This is what we're going. This tool we're going to be using. There are other tools you can use to tackle to do SQL or to work with this. You have the SQL server. I also have that here. That's SSMS. I have this, but this let's use this because this is what everybody's supposed to have. So there are a whole lot of tools. So, but common ones, you have this. You have Postgres also. There's a Progress workbench that you can use. And then this structured language has a whole lot of varieties. You have SQL, which is the Microsoft SQL. You have MySQL, which is this one. It's open source. You have Postgres. You have Oracle. They are all structured query languages, though they just have a little bit of difference in maybe their syntax. But in terms of the language in general, they are very similar. So this is what the view looks like on the MySQL workbench. So at this navigation pane here, you can see the administration panel where you see your server status, you see your connections and all of that. If you down here, okay, so you can navigate here, you can come to your schemas. The schemas are basically your databases. So there are some default schemas you have that come with installation, and then you can also create your schemas. So I created this sales schema, and you can see tables. Okay, so there are no tables in here now for now, so you won't see anything. But if we have tables, you'll be able to. We'll create a table. So you see your tables, you see your views, you see your store procedure, and you see your functions. So here is your query window. Excuse me. Here's your query window where you execute all your queries. Here's your add-on where you can search for whatever it is, like a sort of help guide. And here is where, sorry, excuse me, you get all your feedbacks. So your action output basically tells you if you have any errors. Sorry, excuse me. Sorry. If you have any, sorry. If you have any errors or if any of your queries are successful, so you have this pane here. So this is what we're going to be working with. And
Yeah, sorry,
Gradually,
sir. We should take a break.
yeah, no problem. I'm fine, thank you. So this is what we're going to be working with basically. So yeah, it might look a bit strange now, but as we go on, you get acquainted with it, and then it becomes like just a baby tool. So SQL has a variety of syntax. That is what actually makes SQL, like every other programming language, functional. So let me come back to this slide. So like I said, it's called structured query language. So you're querying, you're asking the database a question. You want it to do this and you need an answer. So yeah, like it says here now, you're trying to retrieve rational data from a relational database. Okay, that's using SQL queries. So there are some set of syntax you need. We're going to talk about. We're going to use also during the process of this course. We're going to talk about the select clause, the where clause, the group by having, and top n, distinct, fetch. Okay, these are some of the queries we're actually going to use, the syntax we're going to use to pull data, to ask questions from our database. Okay, 1 second. Okay, so let me just give you like just a brief just example. So for example, we want to pull data from the database. We want to try to find out exactly, we want to see everything in the database. Okay, so you can say something like, okay, so this is an example here. Yes, picking a particular column, saying select customer key as customer ID. Yes, you're renaming. You can do some functions. You can tell it where you want it. You can give range. You can also group by. You can say, okay, you want it to have a particular parameter, and you can also order. So it's just like you're talking to the database, like I said, you're asking a question. You're telling it to select and name it as something. And you're also telling it where to pick from. Okay. You're telling it from here. You're telling it a range. Okay. You're being specific. You're telling it to group. You're asking it that, okay, I want it to have a particular value and I want you to order by this. So it's just a short, just an example. One of the things about databases basically is that you have different data types, okay? So if you're working with database, you also talk about data types. So there are a variety of data types aside from the syntax. So we have the integer, we have variable characters, we have numbers, we have decimals, we have, let me come here, let me give you, okay, so here I have a table somewhere here. Okay, good. So let me, because I said I want to be as practical as possible. Okay, so we have a whole variety of data types. Okay, so if you can come here, you can see on your SQL, you can see a whole lot. So we have big integers. Okay, we're talking about large numbers. We have binary, we have bits, we have just normal characters, we have date and time. We have date and time, different date and time format actually. Okay, depending on what you want to use. You have decimals, you have floats, it can actually accommodate geography, you can accommodate geometry, you can accommodate images, because actually images are also data. I have to work with images sometimes. Currency is also there. Non-characters are there. Max. So you have variable characters of sizes, various sizes, and then you have real characters, small integers. There are a whole lot. So, but for now, we are just going to be working with a few of them. So we're working with integers. We'll be working with integers. We're working with variable characters. We'll be working with date, working with date time, working with decimals, working with floats, working with strings, working with strings. Yes, I think this is what we'll be working with for now. Though depending on the kind of depending on what kind of project you're handling, you definitely have to scale and push more. But for now, as a beginner class, let's work with this. So I would explain each and every one of this. Don't worry, I will share the material after the class so that you have a proper read. But let's just know what each out. So like I said, integers just like what they are, they're numbers, basically. Integers are numbers. So you're talking about 1 to infinity, 1, 2, 3, 4, 5, as much as you can get. So those are integers. And when you are trying to express integers in SQL, you just put them as just what they are: 1, 2, 3, 4. Those are integers, etc. If we're talking about variable characters, no, now variable characters could be, they're usually more of string characters. That's what is here. Okay, but I probably kept this so you understand better. So you're talking about string characters. So when you're talking about string characters, you're talking about letters, alphabets, or a mixture of alphanumeric. So that is, you're trying to express some, and when you want to do this, you have to put them in quotes. So you're saying, like, you want to write my name, Habib. Okay, you want to write John. Okay, you want to write Mary. So variable characters come in quotes. You have to put them in quotation marks. If not, SQL will. So if SQL sees, if you print this, SQL will know that, okay, this is actually what you're trying to put into that particular database. Then we have dates. Dates come in different formats also. You have, you could, also you have to put the date format in quotes. So you could have your date as, sorry there, 2020, today is 19, if I'm not mistaken. 10 and 11. This is a format. So you're putting the year, the day, and the month. You can have 20, sorry, 20, 11, 18. You can have this format. And in some databases like Oracle, you have them like this. Today is 19 November. Sorry, 2022. So these are various formats also for your date. And then we have date time. Date time basically is just like what it says, a date and time. So you are taking the date, this particular date, and you're adding time. So now, so SQL gives you as much as 2 milliseconds. So you are saying today the time is 12:30. This is 12:30 seconds in, and you have this. So this is what your format is going to look like when you're talking about date time. Then we have decimals. Decimals, like our normal school decimals, are numbers that have fractions, that have decimal point at the end. So we're talking about 1, 1.2, 1.5, 2.9, 35.6. So, and for decimals also, okay, we'll get there when we are actually talking about creating tables. So each of this, for decimals, you have to specify, we are bringing it into a table. You have to specify your the whole number and the fraction. So that means you're going to specify what digits you're working with. So if you're working with 2 digits, that means you're not expecting to have anything from 99 upwards. So everything you're working with is from 1 to 99. Then you now want the fractions to be 2 digits you specify. So for example, if you are going into a table with decimals, you are going to specify that you want, for example, let's say, let's just, okay, let's say, okay, so you are going to do something like this. then you specify. So you tell the decimal place you want it in 2. Okay, so this will actually let SQL know that you want your whole number to be not more than 2 digits, and you don't want it to be more than 2 decimal places. So whatever it is you are putting into that particular database, it will round it up to 2. And if it's the whole number can't be rounded up, it will actually flag an error. Then we also have floats. Floats are like decimals, but they're actually they can be represented, but they are not numbers basically. Okay, so but you can have floats of having decimal points after them, but you represent your floats like this. The quote also. Though your floats can sometimes be added and all of that, but so that you don't have a bit of issues trying to do numeric values in your float, you try and just work with decimals is always better. So like last I said strings. So we have strings. Strings are basically just variable characters. They are letters, they are words, they are alphanumeric. Okay, so they are variable characters basically. So this is just you just identify it as the variable character, and then you are saying, let's say for example, 1A. Okay, so SQL will not take 1A as a number. It's not a number. It's not an integer. It won't take it as that. It will take it as you are either bringing it as a variable character, or you can only bring it as a variable character or a non-variable character. We'll talk about non-variable characters later. So this is actually a string now. It's actually not a number anymore. So those are some of the data types. There are other data types that you would end up meeting. You might need, sometimes there are cases where you might need to convert. Okay, for example, you might be working with things like, I showed you something about geometry. So you might be working with things like latitudes and longitudes and all of that. And you need to create columns for those people. But for now, based on the scope we're trying to work with for this first week, let's try and work with this. So so now let's dive in. I think we all have an idea of what the data types are right now. So I have a script here which I'll also share with everyone after the class. So one of the things about the database, the data itself is the database itself, SQL, is that you could work in a situation where you already have a database, or you need to create a database yourself. So, but now we are starting from the scratch. We want to know how to create the database. We want to know how to create our tables. We want to know how to put values into those tables. We want to know how to extract values from those tables and manipulate data in those tables, basically. So I'd already created a schema here. I've already created a database here called sales. So, but so I have a script here that says, okay, so to create a database, basically, okay, let me delete this. So let me drop the schema. Just drop it. Thank you. So let's start from scratch now. So one of the things you get to do is we're going to create a database. We're going to create our schema. We're going to create tables. We're going to insert values into those tables, and we're going to also access the values that we put in those tables. So you can see I have a script here. Okay, the script basically says create a database if the database doesn't exist as sales. Okay, so like I said earlier, you are making query, you are talking to the database. So it's simple, create database if not existing. That means that database must not be existing. Okay, that's all this query is saying right now. Is the database existing? If it's not existing, create this. So for MySQL, for SQL, you might not necessarily need to highlight the whole column, the query. But for MySQL, you actually need to do that. So okay, I don't think I talked much about this. Okay, so up here in your query bar, you have this button for open, you have save. So open is if you have an existing query somewhere you want to bring into the query, you can do that. You have this if you want to save your script, something you've been working on. You have this for execute, and then you have this execute under a key cursor. You don't really like, and then you can also search and expand an executed you can also expand, like open, set a particular thing you want to execute. Then here you actually created a limit of rows you can actually run here. That's about 1,000, which I think is okay, because so that your work doesn't get too cumbersome. Sometimes you work with a whole lot more, but let's create a limit for that. Okay, so first what we're going to do now is that we're going to actually create our first database. So we're going to create that now. So like I explained earlier, this is our query, and this is our action output here. So I believe you can see under this action output, there is a tick here. When I dropped the database, you can see there was a tick here. It dropped the database. Okay, I deleted the database. So now I'm creating it back. It has created this database here. Create database if it doesn't exist. Let me hide this. Okay, better. So you can see the action. This is what I told it to do, and this is my action. One role affected. Okay, so it also tells you how long your query takes. We'll get to this bit when we start doing a lot of queries. So you can see, we can't see, this is our schemas here. We can't actually see the database here. So what you do is that you come here and refresh. There's a refresh button here. And you can see it here. You can see our sales. So if I click it, you see tables, you see views, you see store procedure, you see functions. So now that we have created our database, it's actually empty. And we also need to select that particular database. We need to tell MySQL that this is the database we intend to work with. So we use a function called use. Okay, so basically what the use actually does, you are telling it, this is what I want to use, just that word itself, use. So we want it to use this particular database, SQL, the sales database. If it was another database we're running, let's say we have another database for farming or something, and that's the one you actually want to work on. If you don't, SQL will not automatically pick anything. It will go to the master and to tell you whatever query you are running, it will actually flag an error. So you want it to select the particular database that has the tables that you want to work on. So we are now going to tell it, execute now that we want it to actually use this particular database. So once you do that, you can see your action output it has done that again, and you have a green tick. Okay, if it actually didn't work, for example, let me change it to sale. Okay, let me run this. You can see use sale error, unknown database. It can't find out the particular database because it doesn't exist. So this plane here is actually very important. It tells you where your errors are and gives you a hint of where you can, what exactly you are doing that is wrong. So let's go back and select our previous database. So it has selected our database. Now, well, after selecting our database, we are trying to put values into our database. It's currently empty. We can't, there are no tables, there's no any form of data in it. Now, let's create tables. Now, to create tables in SQL, just like we created the database, we are going to instruct MySQL now that we want to create a particular table. So to create the table itself, we're going to use this particular command, create table. The first one we did was create database. We wanted to create a database. So we said create database. So now we are going to create table. So we're going to create a table, and we're going to give the table a name, okay? Because it just can't be blank. Okay, so we're going to give the table a name. So for this reference of this, we're using the table, and we're giving the table the name test. Okay, so giving the table the name test. Now in tests, okay, now the structure of tables, let me bring this back. This is a table here, for example. These are our tables. So here's a table, okay? Now, if this table is our test, we said we're working with relational databases structured. So we're expecting rows and columns, right? So here's a row, here is a column, here are our rows. We have a table, but it's blank. Okay, we are going to create the table, and we are going to need to put values, what we're expecting to see in the table. So we're going to expect to see, you can't just create an empty table that you're expecting to see rows, you're expecting to also see columns. Okay, so we're going to create our columns first, because our columns hold the variables of the table before we get to the rows. Okay, so we're going to tell it to create tables, and then we're going to tell it, we're going to also create a column for it. Okay, now when you are creating your column, you are going to define the type of data you want to be in your column. Okay, if it's going to be an integer, if it's going to be a decimal, if it's going to be a string, if it's going to be a float, you are going to determine what kind of data you want to put in that particular column. I believe from the Excel class you had worked with some data that had variety. I think I saw some of the questions where you had data that were in they had columns were in currencies, and then you had some that were in they had text and all of that. So those are data types. Okay, you are going to specify. You're going to tell SQL, okay, you want this particular type of data in that table. So for now, let's just create our first table and our first column. So I'm creating this. Excuse me. I'm creating this table, and I'm creating a column called tests. Okay. Okay. No, let me make it easier. Let's don't let it. Let's call it tests. Let's call it let's call it num. Okay. So we're creating a table and we're creating our first column called num. Okay. So it's a decimal. It is a decimal. So we're also telling SQL now that we don't want values that are more than 5 digits. That is the maximum values that are going to be. From this script now, we're telling we don't want more than 5 digits. Okay. And then after the 5 digits, anything after for the decimals, you don't want it more than 3 decimal places. Okay. That is what this 5 and 3 is saying. The first one is telling you that your number, the values in this table should not be more than 5. You can have less than 5 digits, it will take it, but it can't be more than 5 digits. It will flag an error. Okay, and you don't want it more than 3 decimal places. If you are putting anything that is more than 3 decimal places, MySQL will round whatever figure you have there to 3 decimal places.
And
So
then
when you
those
are
sorry, they didn't give space to upload any documents.
Hello.
Yeah, suppose I just remembered now. No.
Would you like to upload?
Hello, someone is. Can you please mute your mic? Okay,
Sorry
so
for the interruption.
no problems. So you have to, like I said, you have to define what you want in your particular column. So when you're creating a table, you have to be exact, you have to be precise, and you have to be careful, because sometimes you might not actually be the one using the table that you're creating. Even as a data analyst, sometimes you have to just create, okay, this is what the business wants. The business might not even know what they want, but you are trying to think for them, and you are not the one entering the data. So there's no problem, and they're saying that what you gave us is not working. We can't. The front end people are saying they can't access your DB and all of that. You have to be specific, and you also have to pass on that message. Okay, this is what the data you want to work with. This is how you want it structured. So this is a decimal, and we're saying this is what we want. We can reduce it. We can say we want it. We don't want it to be more than 2 and 2. Okay, so now let's create this first table. So you can see again our action output is reading what I just did right now, and it's telling me the number of rows affected. This is telling me no rows because we have actually not put any data in any row yet. Okay, so now it now brings me into to the next portion of this class, where we talk about inserting data into a table. So I won't, okay, let's see. Okay, so now we have created our table. If we refresh this, you can see under sales now table, there's now an arrow. If you click it, you can see, okay, you can see the table we just created called tests. Okay, you can see, if you also click it, you see the number of columns we have, and there's only one column we've created so far, num. Okay, so you can see that. Okay, so table inspector. tell us columns. Yeah, okay. So if you come to table inspector and you come to columns, it will tell you the type, okay, of data you have in each of your columns. Okay, so for this first one now, you can see that we have the table name, you have the data type, which is decimal, okay? You have nullable. Now, this nullable will also get it. This means that you are telling your table, you are saying, can your table allow null values or not? Would get there gradually. Then you have triggers, foreign keys, and all of that. Okay. So, but we're not looking at that yet for this class for now. Okay, so now inserting data into your table, okay, is the next point of it. So to do that, the language basically is this. You are going to insert. Copy this. So it depends. So like I said, there are different structured languages. There we have MySQL, we have SQL, we have Oracle, we have Postgres. So depending on the particular language, because sometimes you might get somewhere and then you see that it's different. You're wondering that why is it different? So inserting now, for MySQL, you can do insert and put your table value and you'll be fine. But if you are talking about SQL, you have to say insert into. Okay, then you now put your table value. Okay, so some of them accept a little bit of wiggle room, some don't. Like that's why I said earlier that the syntax are usually the same, but just a bit flexible around it. So, but for this, you can just say, you can also use insert into in MySQL, it will work. But MySQL allows you the wiggle room to just use insert and put your table and put the values. So you have to put your insert, then you have to tell it where you want it to put it into. You're saying insert into this particular table that we just created, test. Okay? And then you are describing your value. Okay? So you're describing your value. What value are you putting? Now, we only have one column. Sorry, please. So we only have one column in this table right now. So it definitely, it's automatically just going to pick and tell you, okay, it's going to recognize that, okay, this is where you are going. But sometimes you don't need to actually put so much. But if you haven't, we'll do a table that has multiple. So you see how that is. You know the values you are going to put, because also when you're inserting your values, you're going to put them. You're going to arrange the values that you're inserting the table according to how you arranged it. So for example, if we have other columns here, if we have another number one, number two, you're going to arrange what it is that you're going to insert in that order. You don't mix them up. If you put what is in number two as the number one spot, it won't work. Okay, so let's quickly just insert this. I don't need to run this. Let's just insert it from here. So we're saying we want this to be in tests, and these are the values. Now these values is telling you that what are the columns in your table. Okay, what are the columns in your table? That's what it's going to work with. It's not going to work with any other thing. But because we only have one column, we're only going to put just one value. So let's run this particular script. So good. Make many help errors. So I like to work with errors actually, because when you make mistakes, debugging is one of the things that actually makes you a very good programmer and even a data analyst, because then when there's a problem, at least you know where to look at. So now there's an error here. Okay, it's telling me that my value that I'm trying to put here right now is out of range. Okay, created as a decimal. So hold on 1 second. Yes. So let's run it again. Elements out of range. Why are you out of range? table is insert. Let's run insert into. I'm supposed to pick the first row now. Please hold on. Don't know why. So sometimes these things happen and you just have to find a way to. Hold on, just give me a minute. Hello, sorry about that. I needed to create a permission for myself on the system to start doing some few things. Okay, so sorry. Where were we? Okay, so let me add another value. Say 12 to 3.8. Let's see if that works. Okay. So sorry about that. So I've inserted my values back. So you can see insert into, I've created the value. Okay, so basically what happened was I needed to actually create a permission for myself. I have not done that on my server. So so now let's have a look at the table. Okay, so we have this already, okay, and we have our table test. So we've inserted values into it, and we have, I think, at least we can see it. This is run, okay. So now we need to see what we have done, whether the values are actually, even yes, that's told us it's successful, but we need to be able to query and see, okay, what do we have? So for us to do that, there's a query, a function called select. So select basically, just like the word, they are selecting, you're saying this is what I want, okay? And then you have this asterisk here. This asterisk in SQL means all. You are saying you want to see everything in a particular table. So you see select asterisk from, it means that your query is saying you want to see everything. There are also other methods you can use to do select. You can say you want to do select top one. Let's remove this. So select top one means that you want to see the top first. That is the top one value in that particular table. You can say select top 100. You can say select top 1000. It's depending on how convenient you are. But right now, we want to see everything that our table actually currently holds. So let's do that. So we are saying select all from test table. Remember, we created a test table. Okay, so now we have two values. Okay, so now this is actually a result. And like I said, it's always good to actually look at what your action is actually saying. Now you can see two rows are affected. You return two rows. Okay, now these are a column. Okay, and we have two values. I'd actually inserted two values. Okay, when I was running. Okay, so that was the first value we're trying to put. And remember, okay, sorry, I changed it also. I was talking about decimal places. So I actually did this to 3. Okay. So you can see this is what it's going to give you. 0, 0. So we have these 2 values here right now. Okay. So we can actually insert more values. Okay, let me insert into the same test this value so you understand better what I'm trying to say. So now it comes up with a message and says one was affected, okay, and truncation of the column. That means what it has actually done here now is that it has actually put in this value, but it has also truncated the value. That means if we run through our select query again now, you see what we have. Can you see that now? That it has this is actually what we put in, okay? But this is what we have here right now, okay? It has actually truncated the value. It's going to round it up to the nearest decimal, which I've actually stated up, okay? So let me drag this plane down a bit, okay? So that's about inserting values into a particular database, table, okay? Now we have created a database, we have created a table that has a column, and we have also inserted values into that particular table, and we have successfully called out the queries. Okay, we've seen the values in that table. Please, is there anyone that has any questions before we go into the next portion? Hello? Okay, someone is raising their hands.
Okay. All right, sir. Good afternoon. Well done, sir. So my question is in entering, or rather in querying the database, or maybe in querying is it case sensitive? Because I can see that you, for some words, you typed in capital letters, and for some you typed in lowercase. So I want to know, is it case sensitive, the query language, so that if you type the other, okay, like that's select, I think before you type it as a capital.
So SQL generally is not case sensitive. SQL, MySQL, Postgres, they're not case sensitive. Oracle is a bit case sensitive in some aspects of it. So, but this is what we're working on right now. It's not case sensitive. You can bring in any of your syntax, any of your functions in uppercase. You can even, okay, so I can actually even do this. And it will run. Even though best programming practices is if you are going to start with small cases, use small cases. That's for your functions. If you're going to use it, you're going to use capital cases, use capital cases. That's best practice, so that it makes your code easier to read, okay, and makes a whole lot of sense. Because if you just come and see, I put, especially when you're writing complex queries, and then you find out that you are stretching, you're putting, someone is in your code and you have small cases somewhere, you have big cases somewhere. It can actually be confusing to the person. Okay, so when you start writing complex queries, it's always good. Best practices. If you are writing in small cases, use all small cases and you'll be fine. Except in cases of like the name of the table or the database. If you are putting that in caps or any of those, you need to actually put it exactly like that. Okay, the tables on your database must be represented exactly how they were named. But for the functions themselves, you actually don't need to actually be case sensitive about it. But except, which is actually the best way to go about it, is to use the best coding practices. Do we have any other questions?
Yes, sir. Thank you, sir. So I was going to also ask, for the software, this MySQL, I have done it successfully, but to now get to this page that you have is the issue. I know it's on my system, so that I don't know whether.
Okay, so what I'm going to do is that we're going to take a short break now. So when I come back, I'll also share a link. I think I just checked the link that was actually shared. What you actually only downloaded was the MySQL workbench. So that was just the front end tool. None of you have actually downloaded the server itself. And if you don't have the server, you'll not be able to actually make queries and all of that. So you won't be able to connect to your DB. So I'll share the link now with a video and the link of where you would be able to download the server itself and then run the full installation to actually have exactly what I have right now. So let's take 10 minutes break, then we'll
Mr. Habib, I have a question.
Okay.
Please, thank you for the class. This is my first time of learning this programming language actually. So the whole thing is just looking strange anyway. First of all, I want to understand how you were able to create the tables, the database and the tables. I'm yet to understand.
Okay, so let's go back to the workbench. Okay, so first thing we did was create a database. So there is a syntax, a function called create, okay? And then there's database. So you are basically, like I said, you are talking to the DB. Let's simplify it like that. You are telling the server that I want you to do this. Programming languages, just like what they are, you're communicating with the system, communicating with the computer. You want it to do A, B, C. And like we know, our elementaries back in school, they say computers are garbage in, garbage out. Is what you feed in, it's going to give you back. So for each of these languages, they have syntax, they have functions that you use to actually communicate with the system. So, okay, let's create another database for this. So this is the function that you're going to use. So we're going to say create. Okay, I want to create a database.
You are the one that you type the.
Yes, you type what you want. You are going to instruct the computer. I already have this on ground, so I'm just importing this from something I actually already worked on.
Okay.
That's why. So you just tell you want to create a database. Okay, let's give the name of the database. Okay, and if you do this, you can see here in the action flow, products, it's been created. If I refresh here, I'll see another database called products. Okay, in your schemas, you see that this is a database called product. So you are the one imputing the values of what you want. You want to create a database, and you've told the system, create a database. So what this actually just entails is that this is from something I've done earlier. Okay, so basically, the only thing I did here that is different is I told the system server that I want you to create a database. If the database does not exist, okay, it should create it. So if I run this now, it will tell me that it exists. It can't create the database. You can see there's a message down here telling me it can't create because the database already exists. Okay, so I'm just adding a bit more information to what I want. So this is in case when you are getting into a new system and you have in mind that, okay, this is what you want to do, okay, and you're just trying to be a bit thorough. You can say, okay, do this if this is not available. If it's available, it will actually tell you, and then you might need to maybe rename it and all of that. And just like creating the table itself, okay, so now I've created this database. Okay, how do I access this database? I want to store a value in it. I want to create a table in the database. I'll just tell it I want it to use products. Okay. You plug in this guy. Okay. Now I've told it to use product. Now it has selected this particular database. So if I want to actually create a table in this particular database, this is the database I'm working with now. Yeah, also, as I selected use product, okay, you can see that right here in schemas, okay, it has selected products. If I tell it that it should use tables, if it's use sales, okay, and I do this, okay, and I refresh, should actually select, okay, sorry. It's because I select this one. So you can see once you select it, comes here, okay. So, but now I want to create something inside here. Let me come here. Okay, I wanted to use product to create a table. I want to create a table inside product. So I'll just tell it to create a table for me. Okay, and I want the table to be items. Okay, and I want the table to have columns. Let's say product name, and I want it to be a variable character, and I want the length to be 20. Okay, I also want to create product ID, and I want it to be an integer. Okay, I don't even need to specify. Just let it even just be an integer. I want it. I don't want it to have a maximum value. Okay. Let me select this now. You can see I've created a table. If I come here now and refresh, I'll see that table. And if I come to the table and I come to columns, you can see this. Okay. Are you with me?
Yeah, I'm with you.
Okay. So now I have 2 columns in this table. Okay. So now I want to, let's put data in the table, right? So let's see, insert set to items. So I want it to be, let's say, Milo, comma, and I want the ID to be 2. It should run. Okay. So if we come here now and see, let's see whether this our input is actually there. We say select all from items. We run it. You can see we have our product name and we have our ID. Is it clear, or you want me to come again?
I think as a class, as I progress in the class, I will be able to understand more. But I want you to explain this schemas. What is it exactly?
Okay, so the workbench itself has some windows. Okay.
Okay.
You can see
Okay.
at this end here, this left-hand side here, you can see
Okay.
under here, you see administration, you see schemas.
Okay.
This is your query window. This is your
Okay.
action output. This is like an help desk for you. Okay. So these are your schemas. Your schemas are your databases, basically.
Okay.
Okay. So when you create a database, you see your schemas. If you come to schemas, you see them here. This is because we are using MySQL workbench. Okay. So they here it's called schemas, but generally you refer to them as databases. This is another tool that you can use to actually hit queries. Okay. Here you can see it's called databases.
Okay.
So you don't confuse it. It's the same thing. It's just because we're using a different platform.
This one is SQL.
This is SQL.
Okay. The other one is MySQL.
MySQL. They're actually running the same thing. Okay. Just with a little bit tweaks. Okay. So if in case you come across somewhere and then you're looking for schemas and you see databases, they're actually the same thing. Or you go somewhere and someone shows you a system and you see schemas, you know that you're talking to a particular database. So sometimes you hear lingos like database schema. Okay. You are still speaking the same language so that you don't get confused.
Okay.
Are we clear? Or do I come again?
For now. Thank you very much,
Good.
Mr. Habib.
All right. So let's take a 10-15 minutes break. I'll be back. All right. Thank you.
Where did you pick the money?
we're back. Hello, everyone.
Hello, Mr. Habib.
Okay, so we're back, right? Sorry about this, my voice. Okay, can everyone hear me?
Yes, we can.
Okay. Okay, so okay, let's have a quick recap of what we did before the break. Okay, so we spoke about relational databases, what SQL is, mentioned the popular syntax we're going to be using for this class. That's select, where, order by, having, and each of those syntax actually have their uses as the class progresses, we'll get to see them and what we can actually use them for. We spoke about various data types. We also spoke about, then we created our first schema. After that, we created our first table. We inserted value into the table, and then we also extracted value from there. We wanted to see what we had done, if any of our queries had issues and all. So I think that's where, is everybody okay with the previous section, or we need to go back? Hello?
We don't mind if you can do a recap as well. We appreciate that, sir. Thank you.
All right. Okay, so, okay. So like we said earlier, MySQL has various data types. The data type ranges from integers to variable characters known as varchar. We have float, we have date, we have date time. Yes, you can also talk about strings. We have strings. There are a whole lot. Sometimes you even see varchar, non-variable characters. There are a whole lot, and each you have big. We have big int. We have numeric, if I'm not mistaken. Yeah. So these are just a few of them, though just about 5 or 6 of them were all highlighted earlier. And most of these data types are just as their names actually sound. Integer, you're expecting to see just numbers. So if you are creating a table on MySQL and you set a column as integer, that table is not going to take any other thing aside from integer. So if you put strings, or you put letters, or you put any other symbol, that table won't take it. Okay. If you create a variable character, it can take any form of character. As far as those characters that you're putting in it, you have string values. You have quotes around them. So things like this. Okay. Okay. So, and then we have floats. Floats are decimal. They have decimal points around them, but they're actually not. Yeah, I didn't add decimals here. Okay. They're actually not decimals. They are a bit of string characters, but you expect them just like decimal. Then we have dates, and I mentioned the various date types we have. The whole lot of range of date types. Then we have date time. Date time is just a particular data type that has both date, excuse me, and time along with it. Then we have strings. Just give me a minute. Yeah, sorry about that. So Okay, so we have strings. Strings are words, just like the variable characters. So they are words. They are letters. They could be alphanumeric. So if you're expressing like 1A, or you're expressing um maybe an ID or something like this, you're expecting to put them in quotes. If not, SQL won't read it. It will even flag an error. Okay, so then non-variable characters too. They are just like strings. You're expecting to actually put them in quotes. Then we have big ints. They are large numbers. Basically, you're expecting numbers ranging from hundreds of thousands to millions. So that particular column is expected to hold those large numbers. Then you have numeric. Numeric is also like they're integers and numbers basically. So MySQL is going to see that particular column as numbers. It's not going to take anything else except from numbers. Then you have decimals. Decimals, just like what they are decimals, they're numbers with fractions. So expected, not necessarily expected, but if you put, like if you just input a number like 1 in that particular column, it will come out as 1 point, whatever value it is you put, maybe 1.0 or 1.00. Okay, we actually explain this. Then, hello? Are we clear on the data types?
Yes.
Okay.
For me, sorry. Let me speak for that.
Is everyone following?
Hello, can you please
We are with you, please.
types?
I can't hear what you said. What did
Can
you
you
say?
please recap on the data types?
Okay. So like I said, we have various data types and I've listed some. There are a whole lot more than this. So I listed integers. Integers are numbers. Those particular data types are expecting a feedback that you give them numbers. 1, 2, 3 till infinity. You have variable characters. Variable characters are letters. It could be alphanumeric. It could be a sentence. But for you to express them, for example, int now is expecting just numbers. So you don't necessarily have to put them in quotes. Okay. But if you're trying to express variable characters, you're expected to put them in quotes. If not, SQL will not be able to, MySQL or SQL will not be able to read it. It's expecting, if you put that variable character, it's expecting quotes around whatever value you're trying to feed in. If you don't do that, it flag an error. Then you have floats. Floats are like decimals. They are not decimals specifically, but they have the decimal structure. But you also put them in quotes. Okay. Then we have dates. We have dates. Dates come in different formats depending on what is convenient to you, and then depending on how you choose to structure it. But this is just an example. Dates, expected to feedback dates. If it's not date, it won't take it. So for example, if you have a column that is date and you put something like this, it won't take it. Okay, it's not expecting this feedback from you. It's expecting your dates to have a sort of numerical values. Okay, so although, like I said earlier, there are some systems, very few, like Oracle, will expect you to give that feedback, but not even spelled out like this. Oracle will take it something like this. Okay, this is what Oracle is expecting. So there are different date formats depending on how comfortable you are, but this is actually like the most popular you will most likely find. Then you have date time. Date time is you are merging date and time. So depending on what data is being collected or what particular data is actually on that particular database column and where you're working with, sometimes you get to see data types of data where there's date and time. So when you're talking about things like transactions, people want to know what transaction is happening per minute or what a particular time did those particular transactions happen. So you tend to see things like that. You have date time format. Then you have strings. Strings are just like variable characters also. You're expected to feed numeric or alphanumeric. Then you have non-variable and varchar too. They are same. You're expected to feed either numeric or alphanumeric number. You can also feed numeric, but you're expected to put them in quotes. So for example, for most, in short, all programming languages, don't let me say most, this and this are not the same. Can anyone see my screen? One, I just wrote the same thing, but they are not the same. This is one, this is an integer, this is a numeric value, but this is not a numeric value. It's going to see this. It's going to see this as
Perfect.
it's going to see this as a string or a variable character. So for example, I can do, let me see if MySQL let us do that. Select 1 plus 1. Let me see. I can do another. Yeah. Okay. So you can see I've added 1 plus 1. Okay. It will give us 2. I'm sorry. So, but let me now add 1 plus 1. Okay, so well, MySQL is actually different. If this was on SQL, it don't work. So, but basically, MySQL actually reads it differently. But I think maybe because I'm just running it vaguely. If it was actually on it, we'll run it on a column by itself and specify the data we want. So then let's see if that's actually going to work. So, but basically, this and this aren't actually the same on most database types. This is already saying this as a string, so it's not going to actually multiply strings for you. It's not supposed to add that for you. So when we actually start defining what we want on each columns and we are very specific, you'll see that by the time you add 1 and 1 in quotes, it will actually flag an error because it's actually not the same thing because you are being specific. Then I said we have big integers. So when you're talking about big integers, you're talking about large numbers, okay? You're expecting values of hundreds of thousands to millions. That'll work. Then we are expecting numeric too. Numeric values are just numbers also. It's just depending on how you structure your data in the database that will now determine what you're picking and how convenient it is for you, or what you actually meet in an existing database. Because sometimes as a data analyst, you might not be the one in charge. You might not be the one that created the database. Someone has already created it for you. So you just go and know the type of data, and then that will aid the manipulation you want to do. Then we also spoke about decimals. Decimals are decimals. Anytime, any day, you expect to see a whole number, a dot, and then the decimal numbers behind them. From 1 decimal to 2 to 3, you can specify. Are we clear on that?
Yes, please. One more thing, sir. Can you please fit your screen to see the whole page of this interface?
Okay, sorry, I'm currently using a double screen. How about now?
Yeah, it's better. Thank you.
Okay. Okay. So that's a roundup of data types basically. Then after we spoke about data types, then we now talked about creating databases because in each database, in each system. Hello. Please mute your mic. Okay, so then we spoke about creating databases, a database basically. So in each of this, basically, as you need somewhere to store your data, and that's where we now talk about database. So you're storing whatever data you have in a database. So you have to create one, then now put your tables. And like we said, we're talking about the structured data, talking about structured data. So you're expecting to see rows and columns. That's what SQL, MySQL, they handle. You expect to see rows and columns. So you have to create a database where you store your database, where you store your data. So there's a command line for that. That is create database, to create your database. So you put this command line and you name your database. So we did this. What second one we did? We named it products. Okay. Create this particular database. You say create, this is the command line here. Create database, and then you give your database a name. That name is supposed to, so that if you need to go back, create reference, you say, okay, this database you're pointing to. So we created a database called products. After creating a database called products, we needed to have access to that particular database called products. So we used another command line called use. So this use now points us to the particular database because we have more than one. Okay, and we want to actually we want to communicate to the particular one which just created. So we selected the particular database wanted, which is the products. Then in that product is empty, and we need to put data in it. Relational databases take tables. You're expected to see tables in it. Your tables are supposed to have rows and columns. So we created our table. Okay, this table here is called item, and each table has rows and columns, like we said. So you have to create your columns. Okay, your columns are the variables for that your data. Okay, they are different, and those columns that will now hold the data types we are talking about. Okay, that could have your variable character, could have integer. So we created this particular table now that has two columns, product name and product ID. Okay, and after we created it, we now inserted value. We put something in it because it's just blank. We created the table is empty. Okay, and let me give an example of that, what it will look like if there's actually no data in it. Okay, so let's create this table. Okay, we've created this table. So if we refresh, you should see the table sales under products. Okay, so now let's see what we have in the table. This is what it's going to look like if there's nothing inside. You can see nothing, it just returns the column names. Nothing else is actually returned. So we need to put values, we need to put data into that particular table. It was actually what we did here. We added values into the table, okay? And like I said earlier, if you are going to put values into the table, it's best practice for you to arrange your values according to the way you stated your columns, because now you're imputing values in each row. So for example, you see what we did here. Let me cancel this out. So example, what we did here, we have product name, which is a varchar, and we have integer. So what I did was I put the product name first, and I did this, and I put the int, that's the product ID. If you do the inverse, you're most likely going to get an error because SQL is expecting you to impute the data as the columns are being presented to it. So that's how it's going to run. And that's exactly why when we run the script, and run this query, you could see it puts the product name and the product ID side by side. So if you do the same again, and let's change this to milk, okay, and give it an ID of 5 and run it. Okay, see we have success down here, and if we check this table again, you can see. So now let's do 5. No, yes, we already have 5. And let's see sugar. So you can see there's an error. Okay, incorrect value, incorrect integer value. It's expecting you to give values, but you're not giving, so it won't run. Okay, so you have to, when you're inserting your data, you have to insert your data according to the way you paste your rows. That's best practice, and so that you don't have errors and then you start writing script, because sometimes you can have rows as much as 10, 20 rows, columns, sorry, that you need to put it. So imagine if you have missed maybe one or two in the middle. You have to come back and rewrite the whole query again and then run it. And that would actually give you a whole lot of stress. Imagine if you've even written maybe like 200, 300 lines and you miss just one. You have to do it all over again, and that could be stressful. So after creating our table, we checked what was in the table, which we used the select command, and we said this asterisk here means all. In SQL, if you see select and you see the asterisk, that means you want to see everything in that particular table. You want to see everything. There are some other syntax functions that come along with this select. Okay, so we could have something like select top one. Okay, where we are telling that we just want to see the item in the first row. That's what we just want to see, top first one. That's what we just want to see. So if you run it, sorry. Products. Let me come back here. Sorry about that. Use this. Okay. Let me run this. What's happening? You can run top one. That's strange. Just select all. Wow. MySQL is proving very strange to me, because normally I can run top one on SQL. Sorry about that. So, but I know you can run top one on SQL. So maybe our next class, I'll just give you guys a brief of what SQL actually looks like, all in quotes. But apparently MySQL doesn't let you select top one. So, like I said, there are just some few increases in between. I'm trying to ensure that we use exactly what the general values are, not go around looking for those things that are not available. So, but at least we can select all that is actually here and see it. So, but I'll look for that syntax and find out why it's not actually picking top one. Okay. So at least we pull data from it and we can see what our data actually looks like. Hello, are we all on the same page? Hello?
Yes. Hello, please. Sorry to take you back on something similar to the question I asked earlier. This interface that I'm seeing here, is there no way that this app, this SQL, can display everything at once?
No, it can't. Sorry about that. Even if you are going to run it on any platform, you have. So one of the essence why this is like this is because you need to be able to know exactly what you are doing right and what you are doing wrong. If you are displaying everything at once and there's an error, how do you track it?
Okay.
Do you understand?
Yes.
So that's why you have your query, you have your result, and you have your action input. So it can tell you if there's something wrong and you can trace back your steps. So
Okay.
it's one of the things about programming language generally, because you can run into bugs. Okay, you write a script, you have written God knows how many lines of code, and then suddenly you run it and it's not functioning. So this action output is one of the things that tells you, okay, this is where your problem is. Look around. Okay, this is your result. You're expecting to see something. So if you run all the lines of code and then you run it and then everything is just on one particular page, it should be very, very confusing. I remember you're talking to a computer, so you're expecting an output. You're giving an input, so you're expecting an output. So on all the panels, this is most likely how the setup looks like. Even if you come to SQL here, you can see I actually don't have a functioning table here. Where I have is another DB. Well, I've loved to actually just run a script for you. Okay. I'm
And
sure
so
this
I
one.
was going to ask, this particular app you are using now, you said it is MySQL. The file that was
Yeah.
sent for us to download, though I have downloaded it, but I can't really tell the difference because I'm not familiar with it yet. Is it MySQL that we downloaded or SQL?
You downloaded MySQL Workbench. It's a front-end tool to be able to write
Okay.
queries.
But I was going to say this one that there are some discrepancy. How do we navigate it? But since it is the same thing that we'll be using.
That's why I want you to use this. Okay, so
okay, so what's the major difference?
Okay, so like I said earlier, there are just some few differences in terms of syntax and functionality. MySQL is more of an open source.
So not like an upgraded version.
Not an upgraded version. Okay. So there are different developing houses that create these things. SQL is more of a Microsoft tool. Okay. MySQL is more of an open version too. So it's easier for you to access. So there are some things in terms of the syntax. For example, now I tried the top one and MySQL cannot pick a top one. But on SQL, I can pick a top one. I can want to see top one and it will give me top one. Okay. So it's now depending on the environment you are using, the environment you find yourself and what you are using. I'm bringing the both of them so that at least you have an idea that it's not just one. That's the excess of me bringing the both of them. This is what you were told to download. For you to be able to use this, you need to get a sort of premium license to use this, which is going to cost
use
money.
the SQL alone.
Yeah, to actually enjoy the full value, you are going to need a sort of premium license because you're going to need to get a server and all of that.
Okay.
You get so, but this is open source. You can download the server onto your system free of charge. You can get a community version and you get a free of charge version and all of that. So that's why we are not telling you to come here. Okay.
But
they basically
we'll be using the SQL as well.
No, you'll be using MySQL to do everything. All your labs.
Okay.
All your labs right now, you'll be using MySQL. For example, I can look at what is here right now. Can you see my screen properly?
Yeah.
See, can you see this? Select top 1000. Okay. If I say I want to see select,
I can't see that. Select. Take care, sir.
So thank you. So can you see this? Can you see my screen properly? Let me see if I can increase the view. Oh, zoom. This one doesn't have zoom. Sorry about seeing. But can you see my screen?
I can see your screen, but where you place the cursor, I can't see it.
Oh, okay. So let me write this query back.
Okay.
Select. Can you see it now?
Yeah, I can.
Okay, select all from tests. So this is a table I created on SQL. The same command I'm running on my SQL will give me this. Can you see I said select all, and it's that asterisk.
Okay.
Okay, it runs the same. It's just some little tweaks in functionalities that makes them different. Okay, and then depending on where the job you want to do and the organization will now determine if they are more open to the open source MySQL. Fine, you have your database in MySQL and you'll be able to use the functionality. If they are coming to, especially if you're working around banking, most likely going to meet an SQL database. They will not want to go into open source. They want something in an enclosed system. Okay. But if you can use MySQL, you can use SQL. It's just those small things that do not there, which will not really hamper your work.
Okay.
Okay. Because here now I can see it. I want to see top one. The top one that actually wasn't working over there. So let me show you what I'm trying to say. Top one from tests. Why? Okay. Hold on. Okay, sorry. Let me bring the DBO back. Sorry. Why? Okay. Hold on. Okay, sorry. I made a mistake. Sorry about that. So I have to put all the columns back. That's why it's not bringing what I want. So now I can see top one. Sorry. Can you see my top one now? Hello?
The data set you highlight.
Can you see it?
Yes.
So I said select top one from this particular table. Okay, so I can see this now. Do you get? So there are just some small tweaks that just makes them a bit different. Do you get?
Yeah.
But you can still end up using all of them.
Now I get it.
Do you get? So
Yeah.
it's because this you need a whole lot of licensing to do this. That's why we're not using this. This is what I use on a daily basis.
Okay.
This is what I use on a daily basis. I'm used to this. But
Okay.
their languages are very similar. Even if you get an Oracle DB, okay, rather than what do they call it? So for Oracle databases now, you need to specify your database name and your table for Oracle. But for MySQL and SQL, once you just call the table, you'll be fine.
Okay.
So those small intricacies just makes them different. It's not like they're actually that far apart. Okay, it's just some small things, and then the level of flexibility they have to do some things. But if you understand SQL, you're fine. Okay, so let's go back.
All right, thank you, sir.
You're welcome. Is there any other person that has any questions?
Yes, I have a question.
Okay.
Yeah, while creating a table, you did please can you go to the table that you were trying to create?
I created I created this table.
Product ID, product
This one.
Yes, you wrote create table, items, open brackets, product name. This variable character, is it that every time we are creating a table, if you list a name, you must always add, if it's a variable character, you add it. If it's an integer, because you added variable character, open bracket 20, comma, then product ID integer.
Yes. So every time you are
every time you are creating a table, you always have to tell SQL, this is a variable character, this is this, this is that.
Yes, every time. It's a computer. So like I said, it's garbage in, garbage out. That's why I made mention of Excel. So let's see this Excel now. Let's create a dummy of what we're trying to do. That products table now. We have products, let's see, product name.
Please fit this Excel for us to see.
Okay, hold on. Can you see the Excel now? Hello?
Yes.
Okay. So this is product name. Okay. And then we have product ID. Okay, just like what we have there, right? So now, this product name now, okay, we want to set it, we want it to take a particular data type. You know, Excel also has data types, right? So fixing Milo, fixing milk. Okay. Now, we are fixing this as 1 and 2. Let's assume that. Okay. Now, on this data type now, you can see this is general. They are both still on general. But if I do this, let's change this to numbers. What is it this one? I come here and I see I want this to be text. Okay. Now this column is now text. This is numbers. Now watch this. I want to put a number here. And I want to put a number here. What's the difference? Can anyone tell me what the difference is?
Yes.
Okay, what's the difference?
One of the product name is recognized as text, while the other one product ID is number.
How is it recognized as a text? How will you tell me, okay, I would imagine I don't know. How do you want to explain to me that as a text?
Because Excel like text to the left, while number to the right.
Good. That's a lovely response. So that's exactly the same thing. Okay. You're going to always tell SQL, MySQL that this is a text, this is a number, this is a decimal, this is a currency. Okay. Once you highlight all of those, then you now put, so every time you are inserting a value, you are creating a table, you are going to list those parameters. Those are the parameters that MySQL is going to use.
Sorry, you said what? My response was not correct.
I said your response was correct.
Okay, thank you.
Your response was correct. So, okay. So every time you are creating a table, as you are listing your columns, you must list the parameters, the data types you want in those columns. Okay, that helps you in your analysis. So for example, now you list everything as variable characters and you put dates there. Okay, you can manipulate it enough that MySQL will take it. Okay, might even take your variable character. Maybe you bring it in from an Excel sheet and it just lists everything as a variable character. So when you're taking it to maybe one of your BI tools, or even if you want to manipulate on Excel, on MySQL, and you're trying to be specific with dates, you have an issue. Okay, you might not be able to use a date function because MySQL is seeing that particular column as a variable character and not a date. So if you are going to pick a date function, maybe you want to do get
You have
dates,
to write it.
you get, so you now have to convert or create another columns variable. If you already stated all of those columns the way they are supposed to be, it will be easy for you to manipulate data when you are doing your analysis and all of that. So it's a very, very strong note that when you are creating your tables, each of the columns on your tables must have their data types. You must include their data types into it. Okay, it's very, very essential. Also, when you're, like I said earlier, what I did with this example. Okay, what I did with this example now. So if after creating your table, okay, if you need to insert data into your table, you are going to follow the exact way in which you created the columns. Okay, you don't just arrange your insert function randomly or anyhow. You have to follow the exact way. So for example, now what I did here, we have product name here and we have product ID. So what I purposely did is I put my integer here and I put my variable character here. It's always flag an error. It will always flag an error. So you have to arrange, you have to put your values in exactly in that order, in the same order as which you created your columns. Are we clear on that?
Okay, yes.
Okay, so let's see if we can do one more thing. There's a table.
Hello.
Hello.
Hello. Yeah, Mr. Ivan, please. We have a question. Please, why
Okay.
For the variable character, why did you put 20 in brackets?
Okay, yes. So when you're creating your columns, you can specify the length. Okay, of your text. You can specify the number for integers also. You can say you don't want it, you want to create a limit on it. Okay, so let me show you something. Sorry, I have to go back and forth. Okay, here's this table. Design. Yep. Can everyone see my screen?
Yes.
Okay, so now this particular table here, I have 3 columns. Okay, you can see decimal, you can see test, and you can see I put one vibes. Okay, now for this variable character, you can see 255. Okay, it's a standard. This just tells you the length. You want the length of whatever text, okay, that's going to be in that particular column to be, it shouldn't be more than 255. So if the character is more than 255, it won't take it, it will truncate. Okay, like what the example I showed you earlier with the decimal, it will truncate. So what I did was I just instructed MySQL that I don't want these characters, I don't want it to be more than 20.
Okay.
Okay, but by default, if you don't set anything, it will set it at 255. by default. If you don't set a value, it will give you. Now, there is a plus side and a minus side for this. If you leave it as a default, now you are giving, and maybe what you are intending to store is no more than 4 characters each, and you're leaving it as 255. Your database will be unnecessarily heavy. Okay, you'll be consuming so much. Your table, sorry, will be unnecessarily. You'll be consuming so much because you have created space. So for every time a character is coming onto that row, it is creating a space for 255, even though you're only using 4. Okay, so you are going to make your DB, your table unnecessary. So it's always good. Best practice also, know the length, okay, of what you need to put in your particular table in a row. If you're not going to use more than 20, keep it the range of 20. Okay, and you use a plus or minus 5. And say, okay, it should be more than 5. Even though leaving it at 255 isn't wrong, maybe you are talking about a column that you know someone's going to write a whole comment. Like you're giving them access to write so as much as they want. Leave it at 255. The person comes and writes his 255 and they're okay. So all I just did there was just specify and say, I want it to be this range. That's all. Okay.
Excuse me, sir.
Okay.
So we cannot do without putting the number of characters at all.
You can't put the number of characters. You can do without it. If you don't, MySQL will give you a default value.
I know what I'm saying, that if we don't, that means, is it possible that we do not include the number of characters and the default will not be set?
It's not possible. It's expecting, it's not possible. It's expecting something to be fed to it, this particular space, because you are occupying, it's counting those characters basically. So that's what is using.
You have to include it on the table here.
Yes, you have to. You have to. It's best practice. But if you don't, it picks a default value for you and leaves it.
Okay. All right. Thank you.
So like what I did here now, I actually didn't. Let me see if I can get. This is what table is this? Items. So let me come here and say table inspector columns. Let me see. Okay. So for this now, so. Look, I think what we're going to do is that let's create a table and not give it any values. So let's create. Let's call it food. And let's call it type. Just name it a varchar. Okay, so type is already class. Let's name it varchar. And let's say time. Let's use time. Let's use I need something. Food type. Okay. Let's create this table and see what happens. Okay, cool. SQL does not even see now. This is part of what I'm trying to explain to you. Okay. Now, can you see there's an error here? Can we all see my screen?
Where is the error? Is it where we have # before lecture?
No, here, down here. Where am I lighting?
I can't see.
This down.
Yes,
on the action output.
Yes.
The red item. Yeah.
Let me see if I can copy it. Let me see if I can copy it. Copy action. Let me see if I can bring it out. So yeah, everyone sees the error. No, it's not copy. It's just giving me. So basically, now, like I said, some of these are just some small differences that if it was in SQL, I can just tell it that I want the default value and it won't stress me. But here now, it's actually flooding me and telling me that I need to do something about it. So now I didn't define anything here earlier and there was an error, but now I've defined it on MySQL. So it's like I said, there are just some level of flexibility that they have. On SQL, I can just go and run it and I'll just have what I want. Just give me everything on a default value at the back end. So if you come here now and say, where's this table? Let me see. We named it food, right? Inspect table. And let's come to columns. You can see the type and it's telling you what it has. Okay. Are we clear, or should I go back and explain?
Please explain again.
So like we said earlier, okay, you asked the question that do you actually have to state what, as in the value, the value of your characters? And I said, normally for SQL, that's on SSMS, you don't have to. You can just tell you what you want and it pushes out for you. But on MySQL now, I just ran the same code, okay? And it gave us an error.
Hey, sir, please, where is that error? And I don't know if I am missing out on something from my view here, from the screen view here. Because
Okay.
when I said they can see something, you said red stuff. I don't think I can. I can't.
Can you see the whole of my screen?
Where I can see from my SQL workbench up to table food.
That's all you can see?
Yes.
Let me see, maybe I need to increase it again. Just hold on, please. I don't know why it's showing half of my screen.
I don't know if that's the same for others.
Is that the same for every other person?
It's not.
No, it's not. I can see everything.
I can see everything too.
Probably our screen is the one faulty, or probably she's making use of phone.
No, I'm making use of the system. Let me
see.
Yes.
But over here, I can see everything over here.
Can you see the whole of my screen now?
Everybody see it. It's now tiny, but yet I can see the whole thing.
Please,
it's now tiny.
Can somebody help me? What can I do? Is it the zoom option? My zoom ratio is still 100. Let me fit it to 50.
Hold on, let me reshare. So maybe you'd see. Hello, please just give me like a minute. I need to pick up this call. So, can you see my screen now full?
Yes.
You can see it's full now.
Yes. Up to this thing.
Okay. So now,
thank you.
I ran this code earlier. Let me run it again. Let me show you what I was trying to do. Let me drop this table first. So you asked the question that, do you necessarily have to give these values every time you are creating your table? And I said, well, based on the system I use, I could just run it and it gives me a default value. But on MySQL, like I said, those are just some of those intricacies that in terms of flexibility that you might not have. So I ran it here. Okay. And you can see there's an error. Can you see the error?
Yeah.
There is an error. So, but now if I specify the volume I want, okay, I'm specifying the size now. And I run it. Can you see that the error has gone? Okay. My table finally executed. Okay. So these are just some of the intricacies available. It's not a showstopper. Do you get? It's not a showstopper. It just means you just have to be a bit more flexible. You have some level of flexibility you don't have here or there. That's just, it's not a showstopper. So every time you want to do that here, you create a table, you define your rows, which is actually the best practice. You're supposed to be able to define what you want. Because if you are creating decimals, for example, and you're adding, okay, let's see what decimals will give us. So let's create another table. name it and let's give it a column of, let's just say ID. Okay, and we are doing decimal. Okay, I just will create table. Okay, can you see this? Now it has successfully created. Let's refresh and see the values on the table. Let's come to, please everybody with me. Now, can you see what it has done?
Yes.
I'm with you, sir.
Can you see what it has done? It has created
ID.
It has created an ID for me. Data type decimal 10 by 0. So that means it's expecting 10 digits. Okay? And
one decimal.
more 0. Do you understand? It has created a default, but I can actually.
Is it necessarily 0 or into one decimal place?
The 0 just means 1, basically. It's
Okay,
just
okay. Yes.
You understand? You have not given it a value. So what happens if, now, what it's going to do now is that if this particular column now, okay, let me show you something. Let me show you what I'm trying to say, why you need to define those parameters. Those are good questions. So now we have created this table, right? Now let's insert a value into it. Okay. Values. Okay. Now let's add values that are more than 10. Can you see there's an error?
Sorry, there's an error in the spelling.
Yes.
Right now.
Exactly in the spelling.
Sorry. Fired. I want to show you the error. Now, good. This is the error I was looking for. Can everybody see this last part?
Yes.
Yes.
The error says it's out of range. Okay? Because it has given me a default value of 10 digits, and I've put something that is more than 10 digits. So it will be out of range. So I have to do
for column that's now.
Huh?
Okay, yes.
Hello? So now it's telling me it's out of range. So I'm restricted to giving it a value of 10. Do you understand? My digits must not be more than 10. Okay? So if you're now working with data that is maybe in billions, do you see what I'm saying? When you're having 12 digits, you won't be able to fit it into here. So you have to actually specify that, okay, you want 10. We'll get to altering the columns very soon. I want us to grab this first. They will not talk about how to alter the design itself. Okay? So, but do we understand this now? Why you actually need to set your values?
Yes. Please, sir, can you now reduce it to 10 and let's see the results?
Can you see that?
I mean the result on the table. Yeah.
Okay.
So can you show us on the table?
You can see.
Okay. Okay.
So
but sir, now while you want to show the results, here, you input select from the table. But the other time you went to a select all. But the other time I think you went to a tool here and it's just displayed it. Is there any difference?
You can also do this. Can you see what I did? You come to the table. I want you to understand the scripting before you start. There's a whole lot of shortcuts. So if you come to the table and right click, you can see the select rows and you do this to give you the value you're looking for.
Okay.
Do you understand? But let's understand the scripting first. There's a whole lot of shortcuts that you might not even need to write a single line of query and you get what you want. But you need to understand the scripting because there are times when you need to get your hands dirty. Okay, so that's now you understand the essence of why we need okay, to give each of our values, okay, their outlines, okay? That, okay, you want to set a limit, you want to do this, you want to do this, okay? If you leave it at default values at times, it could hamper with what you are trying to actually achieve, and you might not be able to pull data into that particular table, okay? So, so today now, so far we have created a database, we've inserted values into it, okay? And we understand data types and why we should create each value, okay, each of our data, why we should add the data values, data types to each of our columns, okay, and how to actually get data from our table. So there's a table I actually have, and I'm looking for it. Okay, I think this is it. Let's code. Okay, yeah, it's let's code. Perfect. Okay, so I want to bring a table in. It's a very, very large table. So let's play with that table before we call it a day. So also I'm trying to make the class as practical as possible, because like I said, I don't know, maybe because of the way I learned programming, I did more of practicals than actually reading, and it kind of helped me a lot. So the truth about all these benchmarks is that it's always good when you do a whole lot of practice than just the conventional reading and all of that. So after this class, I'll leave you with some assignments. We will not have a class tomorrow. I need to actually, because I have this engagement today, and I said anyhow, I just have to get started. So, but I'll leave you with enough labs. And if you have any question, I'm just a second away on Slack. I just need to take a bit time to rest. So I'm sorry about that. But we'll have enough labs. And if you have any problems at all, just chat me up on Slack. There's Habib on Slack. You can send me a DM and I'll be there to respond to you. And if it means me giving you 5 or 10 minutes and then we just come online and do some few things, I don't mind. I'll be available. But I won't be able to just have an online class tomorrow. So no problem. So hope no inconveniences regarding that. Please, I'm sorry. So, but next week we'll have 2 days. Okay, so let's create this table. Okay, so let me remove this table. So this is just a sample table. It has so much data in it, and at least it's enough for us to practice. Okay, so we have created this table. Okay, we can see the table has been created, and you can see the variable character specified 100 and frequency is an integer. So I've created that. Now, let's load this data. It's quite much. Oh, sorry. I'm supposed to edit something at the beginning and I didn't. The DB name is not supposed to be there. Okay, let's see if this. So I want to show you also something about this particular table now. Why I was saying you need to actually arrange everything properly, because query language can be, in as much as, yeah, one of the beauties about it is that you get to see, like, it's like you're doing something and you can actually see it come to life. Sometimes it could be a bit difficult when you actually make a mistake. Okay, so let's run the script. So can everybody see my screen? Hello?
Yes.
I want everyone to see this. You can see how many rows I've actually imported. Okay, we have 11,000 rows. So let me refresh my schemas and come here. This is the new table we just created. Okay, if we come to inspect table and we check the columns, we can see it's exactly what we did. Okay, we have the varchar that is 100. Okay, and we have our integers. So now let's see what the table can actually give us. Okay, let's run some query and see. So if we say select all, it's going to be much, but I just want to run it. No, I don't want to save. I want to run. Yep. So now I'm purposely running this very large tree because I want you to appreciate something. Let me pull this up a bit. Okay, now the action, the action output is telling us now that it has returned 1,000 rows, and we told you to select all. Can we all remember this? What we said here was select all, but because of this limit that we created here, okay, it cannot give us more than 1,000 rows, because if it gives us more than 1,000 rows, it will even take a very long time to actually run the script, and okay, your board will be too. Your board would, you'll not even be able to update data, and then you'll actually be slowing down your database. So it's always advisable to create a limit when you're trying to spool everything, and it's just a bit of it. So one of the things that MySQL has been able to do is that they give you a sort of preview to your data. Okay, they don't give you everything, even though if you want everything, it's possible, but so that you don't have so much data and you're like, wow, why is this so much? Okay, so this is one of the tables. Now this table is dealing with the dog's name and the frequency of how people use the dog names. Okay, so there's one more thing I want us to do today, just one more. There's a particular function called where. Okay, now basically this where function lets you be specific on what you want to see on the table. Okay, it tells you you use it to query the table, telling it you want to see a particular, or you want to see some particular variables, you want to see particular columns, or you want result based on a particular variable. So for example, now we only have 2 columns here, but let's quickly just run through it and let's just quickly see how the where clause works. Now let's see frequency. We want to see all the dog names that have frequency of 1. Okay, now remember, I'm using frequency equals to 1. Okay, we want to see the dogs that their names have frequency of 1. That means it's only appeared just once in the whole of this table. So let's run it. Hello, can you all see my screen? Hello?
Yes.
Yes, we can see it.
Yes, we can see it.
Okay.
Yeah.
So now, this query now has told, we said we want to see all the dogs that have the frequency of 1. Now, our table has changed down here. The only thing before, the first table we actually ran showed us all the dogs, right? With all their frequencies. But now, the only thing we can see here is frequency of the dogs that are just 1. Just 1, nothing else. So basically, the where clause is used to be more specific. You want to see a particular you want to see a particular result based on some particular conditions. Okay, so is where you're asking it, you want to give me this based on this. We can even increase it and not make it 1. Okay, you can look for 2 or 3. So now this where clause has some other functions in between it. So you can say you want to see the frequency. Let's say you want to see the frequency of dogs that are 1, 2, and 3. Use the function called in. Okay, so this in function, basically you are grouping those your variables you want to check. Okay, you want to see if that particular function is in a particular set of variables. So you come here and you say you want to see 1, 2, 3. So now our result has also changed again. Okay, we can see all the dogs that have 1. We can see the ones that have 2. We can see the ones that have 3. Okay, so basically I'm just bringing this in because it's part of the labs I'm going to give you, because you're going to do a bit of conditional query that we're going to do a bit of conditional query just to see what's going on. But we're not going to use more of the in. We're just going to pick just some 1, 2, so that by tomorrow, around 12 tomorrow. So let's have a bit of a chat on Slack on what the labs are, and then if there's any issues, I'll make sure I'm available around 12 tomorrow. It's 1 hour. Let's just have a chat discussion. I think that will also help. So basically, what your where clause does is that it helps you be specific. Okay, you don't want to see everything in table. You're looking for a particular thing. There's a table that is talking about, for example, this is frequency of dogs, or maybe you're looking for a table that has something that has to do with, okay, let's pick one of our tables here, this product table. Yeah, let's see. Let's do something from this items table. Okay. Okay. So we're picking this now, and we're saying let's see where product name. Now, from the first one I did and this second one, please, what's the difference before I run the query?
The quotes, this one is an alphabet, the other one is a number.
Good. Yes, that's very good. So if depend on the data type you are trying to be be specific with, so you're trying to use on the where clause. If it's a number, you know you don't need quotes. If it's a varchar or a string, you know you are going to need quotes. Okay. If you're looking for a decimal, you're not expected to put just a single digit number. You're supposed to put a decimal. Okay. So now we're looking for the product that is Milo. Let's run this. It will give us the product that is Milo. Okay, so that's the where clause. We'll move into conditional statements not next week, but we'll have a little chat about it, and then I have some practicals that I'll share. I'll share some script with you, some tables also that you can just use to practice and understand some of this. But basically, the where clause is just this. Okay, it now has some extra attachments where you can do between those are conditionals. Basically, you can check between a particular when you're talking about date, or you can check if you are trying to do 2 different things. So for example, now I can say I want to see the product that is Milo and okay, a product, let's say, and the product ID. Product ID is equals to 2. Something like this. It's give us the same answer, definitely, because this has 2. But let's come to these dog files. I think this is it. No. Yeah, this is it. Okay, so let's do this. Okay, let's say we want to see the dog's name. Okay, let's say frequency that is 2. Let me even go back to what I was doing. Okay, this is in this, and okay, the dog's name is Bata. Let's run the script. So you can see it has showed us that okay, we've seen all the values that are inside this, and a particular dog that the dog is Bata. So you can be a bit more specific. We'll talk about conditionals in our next class. So, but at least have an idea of what the where clause can do. So do you have any questions? Someone seems trying to say something.
Mr. Habi?
Hi, Mr.
Yes,
Habi.
Okay.
Yes.
Okay, go ahead.
Oh, sorry. So
Okay, you can go ahead.
thank you, Gladys. Okay, so I wanted to find out like where are we going to get the software you're using, because it's like the other software that you asked us to download is not the same thing.
Okay, so like sorry about that. When after the class, I'm going to share a link on Slack and a guide also to be able to install the full package of the MySQL.
Okay, all right, sounds good. Thank you so much.
You're welcome.
Mr. Habib.
Yes, yes.
Please, I want you to do a light recap on that dog table. do a little recap.
Exactly.
Yes. I don't really understand that table. We are trying to explain something from the table, from that table. I don't really get it.
Okay. So basically what I did here was I brought in this table. This table shows dog names and their frequencies. Okay.
Is the table already stored in the database?
I created this table and I brought those data into the database. Okay.
I know you created the table. That means what I'm trying to what the question I'm trying to ask, is it already existing those tables, or is it already on the database?
Yes, I've already put them in it. I did all of that just right now.
Okay.
Can you see my screen?
Yes, I can.
So this was the first thing I did. I executed this query, create table, to
Okay.
create the table itself. Okay. Then
okay.
I went ahead and added, can you remember this query that we used to put values into the table?
Yes, yes.
So I did this too. I did this and I followed the order. Remember, I said you have to follow the order. The dog name comes first, right?
Yes.
Then the frequency, which is an integer. So you can see that's what I did.
Okay.
Please, quick question. The curly braces in number 6 of the code, is it compulsory? We add the curly braces.
Okay. Yes and no. So traditional SQL allows you to put this. This means that you have ended your query. Okay. That's traditional SQL. It allows
Because
you to do this.
You didn't start with a curly braces, but you're closing with a curly braces.
That's this, right? This.
Yes. Yes.
This. Yes, that's what I'm saying. This particular one, okay, it's not compulsory. That's this that I'm highlighting, or the brackets. Please.
The number 6, the one you are highlighting.
Okay. Yeah, sorry. So this, yeah. So this just signifies that you are done with that particular script. That's the end of that script. Okay. So now, so basically this just tells MySQL that this script is done. So you can actually run your script from here. So for example, let's create another table. Let me just show you what it does. Okay, so sorry. So if I end this, sorry, I can run from here. You know, normally what I've been doing is highlighting the table, the script, right?
Yes.
Hello? I've been highlighting
yes.
it. So if I do this, should run. Oh, sorry, I'm creating a table that already exists. Let me, oh, sorry. Let me come to this DB. Let me use it here. Sorry. Create table trial. Then let's just say ID int. Right? If I do this, it will run. Why is it not picking it? Oh, sorry, I didn't select what I want to use. Product. I just want you to see what I'm trying to do. Syntax is still not clearing. Let me create a new script. Sorry. I think I have too many tables that I have not actually closed their functions. Yes, let me sales. Okay. Okay. Selected this, and I say ID integer. Close it. Use this.
Hello. Hello. Yes. Hello, everyone. I don't hear anybody.
Yes. Hello.
Okay. Okay. I just wanted to find out if you're saying.
Yeah, we are. I was listening to the instructor, but suddenly it just cut off, and I wanted to ask a question.
I think he's trying to share his screen again.
Okay.
Hello, Mr. Habib. Yes, we can. Hello, Mr. Habib.
Okay, Mr. Okay, Mr. Abi. Hello. Come by the next class. If you shared this thing.